Today, more and more people are leaving the city to enjoy the beauty and tranquility that nature offers. Homes and communities are springing up where once only trees and fields stood. While living next to wildlands may offer serenity, it also poses great risk. A wildland environment is a fire environment. Fire in wildland urban areas is inevitable. It's part and parcel of the natural order of things. But that doesn't mean we are helpless in the face of the flames. We may not be able to stop wildland fires from occurring, but we do have a choice about whether or not our homes will survive a wildfire. And the steps we need to take to protect our homes are actually surprisingly simple.
What ignited this house and burned it down were the little things. Now,
For nearly 3 decades, Jack Cohen, a fire research scientist with the USDA Forest Service, has studied the physics of wildfire in order to understand how fire behaves. And in doing so, he has helped dispel many myths that cloud our understanding of fire and inhibit our ability to protect ourselves.
The big problem with our perception of fire in general in our society is that, first of all, we as civilians, as homeowners, can't do anything or don't do anything about fire. Over the last roughly 30 years, I've had that challenged, and over the last 10 years, I've pretty much come to the perception that there are definitely choices that we've got to avoid residential fire disasters during wildfires.
Most people believe wildfire to be a tsunami-like force, sweeping across the countryside, destroying everything in its path, a perception regularly reinforced in the media.
The firestorm rages on across the inland northwest tonight. The wind and dry conditions stack the chips in the fire's favor.
But as Jack and other researchers studied fire, they began to see fire in a different light, not simply as a wave moving along a single path.
I was seeing things during fires that I just sort of filed away in the back of my head, things that didn't quite match what my expectations were. So for example, when I was just a student, I watched a film about a fire in Southern California, and my mental model when I started out watching this film was, well, the wildland fire would come up and get the edge of the community and it would burn those houses down. And yet when I was watching this film, it wasn't just the houses on the edge that were totally destroyed, it was also several blocks inside the community where the houses were destroyed.
If fire proceeded as a wave, why then did homes outside the path of the wildfire burn down? And in other fires, why did some homes, directly in the path of the fire, survive, while neighboring houses burned to the ground? Researchers like Jack believed that if they could explain these inconsistencies, they could better understand how wildfire destroyed homes. To do this, they conducted laboratory and field experiments and post-fire investigations.
When I started on this problem of houses burning during wildfires, I started really paying attention to not only the things that were destroyed during a wildland-urban interface fire event, but also, maybe especially, those things that survived.
In investigations like this one in the Bitterroot of Montana, Jack tries to reconstruct the fire's path to the home. He also challenges the assumption that crown fires, large flames burning in the tree canopy, destroyed the homes.
When I get to a site of residential destruction, I try to get a sense of the pattern of the exposure. We can begin to also trace a chronology, a timing. For example, on the glider, we can see where there was wilt around the glider, and yet under the glider there was no burning from the crown fire. And yet we can also see where the glider was burning from the house. And what that tells us is that the crown fire was long gone by the time this house was burning. I start challenging the idea that the big flames burned this house down. I particularly look for the degree of heating between what was the crown fire and what was the house. And one of the things that I noticed was the foam hand grips. They would have been dripping off, they would have totally been melted away. And these are highly vulnerable to high intensity heat.
Postmortems like this one led to a breakthrough insight.
What my investigations are telling me is that more than half the time the big crown fires aren't igniting these structures. It's something else. It's the little things.
If crown fires didn't ignite these structures, then why and how did these homes burn? In the effort to solve this mystery, researchers applied what they already knew about fire behavior. Fire spreads from ignition to ignition.
Fire doesn't spread by, some magical, whim. It doesn't spread like an avalanche or a flash flood or a lava flow, something on that order. It spreads according to meeting the requirements for combustion.
If homes burn as the result of a chemical reaction called combustion, then the entire process can be broken down and studied scientifically. There are three basic ingredients necessary to create combustion: oxygen, heat, and fuel. Remove any one of these elements and the fire cannot continue. Scientific research determined that home ignitions are caused by flames and by firebrands. Flames directly transfer enough heat to ignite the home. This transference of heat can occur by thermal radiation, when a fire conveys enough heat to nearby fuel so that the fuel combusts. Or it can be caused by convection, when fire comes into direct contact with the fuel. Homes can also be ignited by firebrands, burning embers that fly through the air, land on combustible materials, and directly ignite them. Scientists also investigated the relationship between time and fire and dispelled another widely held misconception.
When we watch a fire spreading through the forest, it may last for hours and hours, but it doesn't last hours and hours at a particular location with those big flames.
It is the twigs, needles, grasses, and other fine fuels that allow forest fires to burn, but it doesn't take long for that material to be consumed.
It's not that the big flames don't provide a lot of heat, it's just that they don't provide that heat over a very long time. So for example, the big flames come up in some proximity to a house with wood walls, and we find that, yeah, it's really intense, and certainly intense enough to cause human injury, but over the period of time that they last, on the order of 60 seconds, it's not sufficient to ignite that wall.
We assume that a fire which burns humans quickly must also ignite wood quickly, but our intuitions are misleading. Humans are far more susceptible to injury from heat exposure. Because most crown fires consume their fuel in a given area in about a minute, they simply burn out before they can ignite most homes or structures. Other experiments revealed an equally surprising finding about fire and distance. Crown fires, even intense crown fires that burn at a distance greater than 100 feet, cannot provide enough radiant heat to ignite a structure.
It gives us an opportunity to change where that fire goes by somehow changing the situation so that it doesn't meet the requirements for combustion.
Armed with this information, Jack formulated the home ignition zone. The home ignition zone is an area that includes the home and its immediate surroundings, which, if properly conditioned, can save the home during a wildfire. The home ignition zone regards property from the perspective of a wildland fire. A house is no longer a home. It is potential fuel, and everything surrounding this fuel is a potential heat source that could ignite it.
The home ignition zone determines the vulnerability of our home to wildfire, and that home ignition zone extends out a couple of 100 feet at most from the house.
Protecting a home begins by reducing the flammability of the home itself and the surrounding property. For example, by switching to flame-resistant roof materials. Thinning out trees can stop crown fires from spreading from canopy to canopy until it reaches the home. And clearing the zone of dry vegetation and flammable objects can eliminate heat sources that might form a path to the home.